Hello everyone, welcome to the class of E-Plan and Electrical Control Technology. In modern life, colored lights are now seen everywhere as a kind of decoration. They can enhance visual impact on people in advertising, add a festive atmosphere in festivals, and even strengthen the lighting effect on the stage of the evening party. Generally, we can use PLC to control colored lights. So, how does PLC realize the control of colored lights? In this lesson, we will design a PLC-based electrical control system for colored lights. First, let's look at the process requirements of the colored light control system to be designed. There are 8 LED lights. After the system is powered on, all 8 LED lights are off. After the control button is pressed, the 8 LED lights will be on in turn from left to right, and each light will be on for 2 seconds. The 8 LEDs are on in cycles automatically. After the stop button is pressed, the LEDs will go out immediately, and the system will be reset. The specific control requirements are shown in the figure. In the system, SB0 is used as the start button, and SB1 as the stop button. Meanwhile, the circuit should be provided with certain short-circuit protection. In the previous lesson, we learned that in PLC, the switch is used as the input device of PLC, and the LED colored light is used as the output object of PLC. Now let's make the I/O allocation table of PLC. According to the name and type of input and output variables, the I/O allocation table of the colored light control system is shown in the figure. The start button, SB0, corresponds to I0.1 of PLC. SB1 corresponds to I0.2 of PLC. And the 8 colored lights correspond to 8 outputs of PLC, from Q0.0 to Q0.7. As there are only 2 states of colored light, on and off, all data types used by PLC shall be Boolean type. After the I/O points of PLC are allocated, the next step is to realize the flicker control of colored lights according to process requirements by programming PLC. According to the control requirements, 8 LED lights shall be on in turn from left to right and automatically cycle, with each light being on for 2 seconds. The specific programming idea is as follows. Press SB0 to set M1 0.0, and the normally open contact of M1 0.0 starts timer 1. When the timer increases from 0 to the target value, read the process value of the timer for judgment. Take program segment 3 as an example. When the process value of the timer is greater than 0 millisecond and less than or equal to 2 seconds, the output coil is energized and LED 1 is on. Take program segment 4 as an example. When the process value of the timer is greater than 2 seconds and less than or equal to 4 seconds, the output coil lights up LED 2. By analogy, LED 1 to LED 8 can be turned on alternately, and each LED is turned on for 2 seconds. How can the 8 lights go on automatically in a cycle? Let's look at the program segment 11. When the process value of the timer is greater than 16 seconds, the reset timer instruction is executed. At this time, the process value of the timer becomes 0. Finally, the process value of the timer always automatically cycles from 0 to 16, realizing an automatic work cycle of 8 LEDs. After the program is written, we can verify in PLC whether LED lights can be controlled as required. If so, it indicates that the programming is correct. Otherwise, the program needs to be modified until the requirements are met. Finally, let's look at the equipment selection of the colored light control system. As shown in the following table, the equipment mainly includes the miniature circuit breaker, fuse, button switch indicator light, and PLC. Next, let's select the equipment one by one. First, the miniature circuit breaker. The brand Siemens is selected, and its rated breaking capacity of short circuit current is up to 6 kiloamperes, ensuring the safety of electrical circuits. Moreover, it has stable performance and high reliability and is not affected by voltage fluctuation. Select the model 5SV9313-7CR25. Then, the fuse. Let's select the fuse element first. The fuse element on the circuit should take 1.5 to 2.5 times the load current, so 6 ampere fuse element is selected. According to the selection table, the model is RT28-326 amperes. Then, select the fuse. The fuse is mainly used with the fuse element. After consulting the table, we select model RT28N-32X base 1P for the fuse on the circuit. Next is the button switch. We select green and black Chint NP2 series switches as button switches. Indicator light. Since the system is powered by 24-volt DC, the indicator lights with a rated voltage of 24-volt AC/DC shall be selected for convenience. Finally, select PLC, the core part. We chose SIMATIC S7-1200 because its controller has strong scalability and high flexibility, which is adaptive to the communication interface of industrial communication at the highest standard. Besides, it has a complete set of powerful integrated technical functions and is easy to design and implement. Moreover, it has advanced application functions supporting miniature motion control systems and process control systems. Select the mode 1215FC DC DC DC. Everyone, just now we learned the design process of using PLC to control the automatic operation of colored lights as required and the selection of equipment commonly used for colored light control. As a modern automatic control system, PLC is widely used in production. It is mainly used for relatively complex control circuits to realize simple connections of equipment and automatically control the equipment to run as per the program according to actual requirements. Due to its powerful function, high reliability, strong anti-interference capability, and ease of learning and use, it is highly favored by engineering personnel. Please practice more applications of PLC in the control system according to what we've learned today after class. That's all for this lesson. See you next time.